finding the pH of a weak base is very similar to finding the pH of a weak acid. So, for instance, what's the pH of 0.1 molar NaCN? Well, the first thing you have to do is realize that this is actually a base, okay? You need to recognize it as a base because it's Na plus and it's Cn minus. Well, Na plus is always going to be a spectator ion. So the important part of this is the cyanide, right? And that's the anion of a weak acid, so it's going to be a weak base. So we'll write our hydrolysis reaction. Okay, we'll add it to water. Need an equilibrium arrow, so HCN and OH minus. Okay, and we've got an ice box and 0.1 molar. Ignore the water. 0, 0. Minus X plus X. Hopefully this is getting familiar by now. They all kind of look the same. 0.1 minus X. X and X. So 1.8 times 10 to the minus 5 is X squared over 0.1 minus X. And we can go ahead and make that assumption because K is pretty small. Okay, so when we do that, what happens is this disappears. Okay, so then if you go ahead and solve for X, you get 0.0013 molar. It's important to recognize here, though, it's not H plus we found, it's OH minus. So we found the OH minus concentration. So the first thing I would do is find POH, right, minus the log of 0.0013, and that's going to be 2.87. And then find the pH by subtracting that from 14. So the pH is 11.13, which makes sense, right? We've got at the equilibrium point, we've got a basic solution, so it makes sense that we've got a basic pH. The other thing I want to cover in this video, I think I did it in class one day, but let's take a look at relating Ka and Kb. So keep in mind, let's see, if we got HF, let's draw a hydrolysis reaction for that weak acid. All right, so we're going to get hydronium ion, and we're going to get fluoride. The K for that is called Ka, right, because it's a weak acid. Well, let's write the hydrolysis reaction for the weak base. So fluoride, let's add that to water, and we'll get HF and OH minus. Now the K for this reaction is Kb because it's a weak base. Okay, and then let's look at this and let's cancel out some things. All right, so the fluoride and the HF, and we come out with 2 water are in equilibrium with hydronium ion and OH minus. Well, what's the K for this one called? Well, this is Kw. And remember, if you can add equations, you multiply the K's. So we're going to get the relationship Ka times Kb equals Kw. And that's going to come in really, really handy when you know Ka and they need Kb or vice versa. So that's going to be kind of a handy thing to know.